Hi, welcome to the Chico Math Lab differential equation problem solving session. All right, so today this is the problem we try to solve here is y squared plus x squared plus x, the y prime minus y is first order nonlinear differential equations with initial condition y1 equal to 1. Okay, so when I first saw this problem, this is like a very simple, easy problem here, right? But this ones here, I tried several methods and seems none of them work. Then suddenly, the method I'm going to show you here worked out. And so I was wondering, did I ever go to like too hard and try to, you know, maybe some viewers, if you know some easier method, I would like to know about it. Okay, so you can put the comments, left the comments layer. And this one's here, I think it's a little tricky. And so, like I said, I tried a different method, and now, none of them work out great. But the last one, the one here, I think is pretty good. Okay, so, but I like to learn if you have any other methods there. So feel free, let me know here. Okay, so just like now I will tell you why I come out with this, the method I'm using here. So this one's here, like I said, I always like to, so this is y squared plus x squared plus x. I always like to change the y prime to the dy dx. Okay, now I also move the y to the other side here. And when I saw this problem the first time, I saw the x squared, y squared, and the x is here. I know I probably need to do some substitutions here. All right. So the one of the good substitution because in here, okay, because in here I have y squared, x squared. So that's why the substitution I was trying to use is like the substitution of x over y. And so I can simplify this. Okay, so before I do that, all right, so that's why this is what I come out with my substitution idea. I will say u is equal to x over y here. So because this is what I want to try, so I will say, okay, let me get my y square out here. Okay, so this will be 1 plus x squared y squared plus x over y squared. Okay, so this is x over y squared dy dx equal to y here. Then this is good, x squared, y squared, that's u squares, right? So that's good. And so now I will just divide by y squared, both sides here. And so after divide, I will have 1 plus x squared, y squared, plus x y squared dy dx equal to 1 over y here. Okay, so now I see here the x squared, y squared is good, but the things that bother me is these numbers here is x over y squared. I have a hard time to change to a u. But then I start to see some things here. I thought, okay, how about if I move the dx here? Okay, so this is a dy. I move the y's here. This is dx here. And the sense caught my eyes is here. So like I said, before I came to this method, I did try several other methods and it become a big mess later, right? All right, so the sense caught my eye is this term, the x over y squared dy and dx of the y. This kind of very similar like the integration factors. Okay, so what that means here, I say, okay, now let's try to do this. All right, so this is 1 plus, okay, x squared, y squared, dy. Okay, then plus, this is xy squared dy equal to the dx over y. All right, so here I keep this straight. Okay, so this one's here, the x squared, y squared, now this is good. So this is u squared is equal to x squared, y squared, right? So this will be 1 minus u squared dy. Okay, so 1 minus u squared dy. And now this one's here, I will have y dx minus x of the y squared dy here. The reason why I say it's good, because this one is kind of like the product rules. You know, if you take the derivative of xy, okay, x over y. So if you take the derivative of x over y, so what do we try to do here? So this is you try to take the derivatives, right? So here of xy. So what is here? So this one's here will give us, so you use the quotient rule, so it's y squared. Right, so that's why I see, because this xy square, because of because of this y squares on the buttons here. So I thought, well, maybe I can use the product rules here, right? So y squared, then the x is here. What is, then the quotient rules here will be take the derivative, hold the bottom, right? So the derivative of x is 1, right? So the 1, this will just be the dy dx times y, right? dx times y here, okay? And then minus, then you hold the top, x, take the derivative of the bottom, y the derivative will be dy here, okay? So this is what I call my here dy. So now, if I combine these two, I will find this is the common denominator y squared. So this one's here will just be the y to the dx minus x to the dy. So did you see here? So I know this one's here, so this is a breakthrough. I finally see that. So this is really is the derivative of x over y. And also x over y here, because I assigned, I assigned x over y equal to what? I assigned x over y equal to u's here. So basically, this side, I will have what here? Basically, this side I have is the derivative of u here, right? So because this one is really the derivative of x over y, but x over y is u, so this is what I have is the derivative of u here, all right? So that, so it's the derivative of u. So that is how do I get here du. Then my left-hand side, this is 1 plus u squared dy. Then I will say, whoa, this is the one. Then now I can do the variable separation, u and the y. So now I will say the dy is equal to du over 1 plus u squared. Correct? Okay, now what I can do here, I can integrate both sides here, right? So after I integrate both sides, then I will have here, I can say here is arctan u, right? Equal, right? So equal y plus some constants. Then here the arctan u, so arctan u is x over y equal to the y plus c. So now my initial condition is y1 equal to 1. So I will have here, so octane 1 is equal to 1 plus C, right? So 1 plus C. Octane 1, I know it's pi over 4 equal to 1 plus C. So what is my C value? C is equal to the pi over 4 minus 1. Okay, so afterward, then I can just substitute. So my final answer will be octane x over y equal y, okay, plus c, right? So so it will be x plus c, c is plus pi over 4 minus 1, okay? Right, so then let's make sure I did not do anything silly. So octane u is y plus c, so it's y plus c, 1, c. That's right, so c is pi minus 4. Okay, so this will be my final answer for my differential equation. Like I mentioned at the beginning, after I saw it, then the whole differential equation become pretty simple. But like I mentioned, it took me a while and several other trial before I recognize these tricks here, right? So it's kind of like when we do the integral, when we try to do the integral factors here, I start to see that. Okay, as soon as I see that, that's the breakthrough, and then I change, make the integrations, and the differential equation is solvable. But like I said, I maybe take there are several different ways to solve it. If anybody have a different way to solve this differential equation, please feel free to let me know. But anyway, I hope what I did here can help you and for this problem solving of the differential equation. It's nice to talk to you and looking forward to talk to you our next problem. Have a good day. Okay, bye-bye.